and electric Roadsters. Manufactured gemstones are typically designed to imitate genuine mined gemstones. Not these. They're made from heather, a hardy flowering plant which grows wild across Scotland. For centuries, Scots used heather to thatch roofs, stuff mattresses, and even brew ale. This Scottish company turns heather into gemstone material for jewelry and other gift items. Heather gems, as they're called, have vein-like patterns created randomly by the plant stems. Therefore, no two gems can be identical. When the hand-picked heather arrives at the factory, its green foliage still clings to the upper part of the stems. After cutting the plants into lengths of about 10 inches, workers load them into a sandblasting machine. The drum rotates for about half an hour, while tiny iron pellets blast the heather inside. The pellets chip away the bark and remove the foliage. The heather comes out of the machine as bare, dried-out, delicate wood. Workers form 1.5-pound bundles and place them in a vacuum dye chamber for 2 whole days. First, the vacuum draws out the air in the stems to clear the way for the dye to penetrate. Then, again under pressure, the stems slowly absorb the dye. This vacuum method is far more effective than dipping or soaking the stems in vats of dye because the color penetrates deeply into the heather wood, rather than merely sitting on the surface. They open the bundles and make new ones of the same weight, this time combining colors. It's important to combine thicker stems with thinner ones to create contrasting lines in the gem pattern. Next, they soak each bundle in epoxy resin for 2 or 3 minutes, ensuring the stems are well saturated. Then they place the bundles on racks to allow the excess resin to drain off. They load 4 bundles between the top and bottom halves of a mold. A press then slowly closes the mold, applying 88 tons of pressure for about a minute. They clamp the mold closed and remove it from the press. Then they put the mold into an oven for an hour to cure the resin. They open the mold and remove what is now a rock-hard, resin-bonded block of heather wood. They put the block on a bandsaw and trim off the rough edges. They cut slices between 4 and 5/10 of an inch thick, depending on what shape gem they'll be making. After gluing each slice onto a plastic backing, a robotic cutting machine guided by a computer cuts the gem shapes. Then workers simply pop the gems off the plastic backing. This domed oval shape is called a cabochon. The finishing team smooths and polishes each gem on a belt sander, then applies 4 or 5 coats of clear lacquer. Lacquering draws out the colors while sealing and protecting the wood. Finally, they glue each gem onto the jewelry or gift item. Sometimes they dye the heather just a single color. This still produces a striking gem because the dye penetrates the wood with different intensities, creating contrasting shades. The signature feature is the unique veining produced by the heather encased within. each and every gemstone truly capturing the natural beauty of the Scottish Highlands. Invented in the middle of the 20th century, instant film made photographic images materialize almost magically. The picture appeared in minutes. No more waiting for days for film to be processed. Today, it's a digital world, but instant film is still getting plenty of exposure. With instant film, you can watch an image develop before your very eyes. No film lab or digital printer necessary. Just say cheese and wait to see what develops. Many decades after its invention, instant photo development still seems like a neat trick. Making the magic happen is a many-layered process, one that involves multiple materials and chemicals. Production begins with the film negative. It takes place in the dark to prevent pre-exposure. The technician dons night vision goggles, allowing him to monitor plastic film as it unwinds into a coating machine. Inside, various dyes and chemicals will transform the film into a negative. They switch the lights back on briefly for our camera. The film travels up and down towards the coating machine. It's a system that prevents any slackening in the feed. The coating is also done in the dark, so this worker demonstrates the process for our camera on a small research machine. Liquid photochemicals and dyes flow onto the surface of the plastic film. He spreads the liquids across the film for an even application. This is all done mechanically inside the real coating machine. Once coated, the film will head into the dryer. The various coatings will dry in separate layers without intermingling. Here's a test tube lineup of the liquid components of the negative. The colorful ones are dyes, and the white ones are other chemicals. They apply black backing to the negative to block light, again preventing pre-exposure. The trip through the dryer is 87 yards long. Hot air dries the chemicals on the surface of the film. Once again, it all happens in the dark to protect the light-sensitive film. Coiled up and packed into light-tight drums, the color negative material is now on its way to a second factory to be assembled into the instant film pack. Upon arrival, they thread the negative onto a machine, along with other materials for the film pack. They include a plastic-based material called the mask and the positive paper that receives the photographic image from the negative. The various materials are steered toward assembly stations by a system of rollers. Here's a lineup of the various materials to be assembled. That's the mask on the far left and the negative in the middle. The negative heads towards a series of hot presses. One press laminates a plastic spacer called the rail to the negative. Another lamination head applies the mask to the positive sheet that will receive the image. On a different machine, equipment folds a kind of foil pouch and injects it with film developer. Here's an inside look at the pouch. The blue liquid is the developer. Encased in the foil-lined envelope, it will stay fresh until needed. Back on the main assembly machine, another hot press laminates the developer pouch to the other film materials. This completes the film sandwich, and it heads into another station to be sliced into photo-sized pieces. The photo frames ride a wheel with a counter that divides them into stacks of 8. Meanwhile, robot arms deposit a rectangular spring on a battery. Then they position the 8 pictures on the spring battery assembly, followed by a light-blocking cover. The stack then moves forward to be squeezed into a plastic cassette. A suction type of device now picks up a cardboard box and transfers it to the end of the film pack line. Another device captures the film pack as it comes off the line and places it in the cardboard box. Once folded closed, the box of instant film rides the carousel to a scale. A quick weighing confirms there's enough film in the box, so it's ready to ship. The assembly of this instant film pack has taken roughly 3 minutes. Now those instant memories are just a few clicks away. A common assumption is that all white sugar is derived from sugarcane. But 30% of the world's white sugar supply comes from the sugar beet. While sugarcane grows only in tropical climates, the hardier sugar beet can be cultivated in cooler regions and in poorer soil. It takes about 7 beets to produce a little more than 2 pounds of sugar. The byproducts of processing, molasses and beet pulp, are used for animal feed. The processing of sugar beets yields various grades of sugar. The lower ones are reprocessed to become white sugar. Farmers plant beet seeds in the spring and harvest the mature crop in the fall. Mechanical harvesters attack 6 rows at a time. They rip the plant out of the ground, chop off the leaves and crown, leaving just the bulbous root. A beetroot typically weighs about 2 pounds. 17 to 18% of that is sucrose, which is sugar. A loader transfers the harvested beets into trucks. The loader's sieve removes about 1/3 of the soil along the way. When the trucks arrive at the sugar factory, they unload the beets, soil and stones included, onto a conveyor belt which transports them to a washing station. First, they head into a revolving drum, where under a shower of water, the beets rub against each other, dislodging the soil. The water flow floats the beets, which then exit the drum. The stones stay behind, collected in separator buckets along the edge. A screw conveyor moves the beets to a transfer system, which brings them inside the factory to be processed into sugar. Inside, slicing machines cut the incoming beets into cassettes, strips about the shape of French fries but smaller. The cassettes travel on a conveyor belt into a large tank of hot water, where they soak for a few minutes. This gets their cell membranes to begin opening, clearing the way for the sucrose to exit during the next operation, in which the cassettes are pumped to the bottom of a 22-yard-high extraction tower. A rotating shaft within the tower transports them slowly upward against the downward flow of hot water. This draws out the sucrose, producing a sugary water called raw juice. The next step is to purify this raw juice. In a giant kiln, they burn limestone with coke to produce the chemical compound calcium hydroxide, also called lime milk. They add it in several stages to the raw juice. Meanwhile, they press the sucrose-stripped cassettes into pulp to sell as animal feed. They add carbon dioxide to the lime milk and juice mixture. This absorbs 1/3 of the juice's impurities, enabling a filtration system to remove them. The raw juice exits as a golden sugar solution called thin juice. The thin juice then enters a 6-step evaporation process, which reduces it to a thick syrup-like juice. From there, they pump it into a 4-phase crystallization system. In phase 1, they heat and add seed crystals, tiny identical-sized sugar crystals made separately, using a complex cooling and evaporating process. As the water in the juice evaporates, about half of the sucrose crystallizes, growing the seed crystals. Then a centrifuge machine separates the crystals called refined sugar from the remaining syrup. The syrup goes through this crystallization centrifuge process 3 more times, producing a lesser grade of sugar each time. The factory dissolves and recrystallizes the lowest 2 grades. The highest grades of sugar go into dryers. On the way, passing through a screening machine which separates any crystals which are too large. The factory dissolves these crystals, then puts the sugary liquid through the crystallization process again. So in the end, there are two grades of beet sugar which go into silos where they're stored until it's time to package them for sale, as refined sugar and white sugar. The electric car ruled the road early in the 20th century, and then the technology was surpassed by gas. Today the concept is cruising towards a comeback, its resurgence fueled by concerns about pollution from gas-powered vehicles and by worries about overdependence on foreign oil. This sassy-looking sports car is leading the charge for change. Just plug it into any electrical outlet, and after a few hours, it has enough juice for a drive through the countryside or for quite a few jaunts around town. With no tailpipe, there are no direct emissions, and if the power generated by the electrical plant is clean, everyone breathes a little easier. But with a price tag in the six-figure range, this eco-friendly Roadster is a luxury product. Production begins with the first half of the gearbox. A worker bolts a brass fitting to the center and then attaches plastic tubing to it. The tubing will deliver lubricant to the transmission's bearings. He inserts those bearings into slots in the gearbox and presses them into place using a hydraulic tool. He drips thread locking compound into screw holes and installs a device for locking the transmission. It's called the parking pawl. He applies more adhesive to screws and threads them through the pawl to the gearbox. Using a calibrated torque wrench, he tightens them to a precise setting. The transmission is single speed with 4 gears, which they install in the other half of the gearbox. These are helical gears. Their teeth are cut at an angle for gradual engagement and smooth operation. They're now ready for the rotor and the stator. Both are electromagnets, and together, they'll be the electric motor's driving force. They insert the rotor into the stator, where their 2 electromagnetic fields will interact to create torque, transforming electrical energy into mechanical energy. They hoist the rotor and stator assembly onto the gearbox and bolt them together. They attach cables for wiring the motor to the power electronics module later. It's a crucial part that processes and regulates the flow of battery power to the motor. This completes the electric motor drivetrain. They lower the drivetrain into the back of the pre-assembled car body. They position the motor mounts over slots in the steel subframe. And once in place, they bolt the drivetrain to the chassis. Now under the car, they pull back the rear suspension temporarily to attach the drive axle to the gearbox. The axle is equipped with a rubber-encased joint that allows a rear wheel to react to bumps independently, without reverberation to the other. The battery is next. Seen here in a display model of the powertrain, the metal pack contains more than 6,800 lithium-ion cells and delivers 215 kilowatts of power. Enough juice to enable this electric car to accelerate to 60 miles an hour in under 4 seconds. Machinery now lowers the car onto the battery, positioning it in the front of the gearbox and just behind the car seats. They jack up the battery for a precision fit. They connect wiring for low-voltage systems like the lights and fans. And now the brains of the electric car, the power electronics module. They install it on top of the motor and battery and wire it to both. With all the wires connected, the module is equipped to convert DC power from the battery to the AC power. It will then supply that current to the motor as the driver steps on the accelerator. With the vacuum system, they drain air from the battery and pump in liquid coolant. Coolant continuously flows through the battery to maintain an even temperature throughout. The body panels are made of durable, lightweight carbon fiber. And with the computer software updated and the car now completely assembled, it's time for a test run. As this sports car accelerates, there's no throaty roar. Unlike a gas-powered engine, the electric motor takes off quietly and quickly. If you have any comments about the show, or you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.